All right, this is our last lecture in section 6.6. This is to go over the two problems that you were supposed to have covered on your own, the vertical and horizontal inequalities. So the problem with x is greater than 2 and y plus x is greater than or equal to 2. We have, first of all, to put the second equation in slope-intercept form, y is greater than or equal to negative x plus 2. And I've done this one in purple, and so I've graphed the line here. It comes down this way, and then I've done the checkpoint above because you notice the greater than or equal to indicates that we would be above the line, and the checkpoint above indicates that that is indeed correct. And then the x is greater than 2. That x is the boundary, x is equal to 2 is a boundary line, which is a dotted line because it's not included, and the vertical line through x equals 2, of course, meaning that there are 1, 2, 3 points here, all with x is equaling 2 and different y points on them. And it says greater than, so that means that the values are going to be to the right of this. And then I checked that with a checkpoint indicating that yes, indeed, that is the solution. Now once these are both graphed, you see the purple and the yellow intersect in this area where I've shaded in with green. So I've highlighted the boundary line here and along here and shaded all this in green as our solution. Okay, now moving on to the second one. We had 2x minus y is less than 5 and y is greater than or equal to a negative 1. And on this one we were supposed to be doing our y is greater than or equal to negative 1. So I put the horizontal line y is equal to 1 here, and it is of course a dotted line because actually it is equality, and so it should actually be a solid line on there. Sorry about that. With the information over there overload, I didn't notice that was a solid line, so let's put that in being solid, and then we'll change this one also as being a solid line over here. So that's greater than or equal to. And then we have 2x minus y is less than 5. So I'm solving that for y first of all. And notice because I divided by the negative here in all of these, then I also switched the inequality here. And so that is the boundary line. Y is equal to 2x minus 5, and notice that it is a dotted line because it is a strict inequality. The inequality suggests that we should shade above it, and I showed a checkpoint here that indicates that that is the correct solution. I did not do a checkpoint for the yellow line, the y is greater than negative 1, but I could have done the origin there, so 0 is greater than or equal to negative 1, and that would be a true statement. And so my solution is where I see both the yellow and the green, which is where I've highlighted with the pink. So I've got the boundary line of y equaling negative 1 coming across here until it intersects with the boundary line that is dotted here, and everything shaded in between. Now you'll notice on this, both this problem and the last one, right here where the two boundary lines intersected, I actually highlighted those for you because those, like I said, are very important points in solving application problems. And so I highlighted those to show you what the solutions were. And the way that we would find those if we weren't able to see them clearly on a coordinate system is we would be solving the system of equations. So we would solve y is equal to 2x minus 5 and y is equal to negative 1, and that would be the solution. Let's go back and look at the other one as well. The other one here, the solution, or the place of intersection is right here, which is a 2, 0, and that again would be the solution to x is equal to 2 and y plus x is equal to 2. So these are the two solutions. Hopefully you got those correct. I'm not going to do any of the application problems in this section. They're all revolving around regression, and therefore I'm not going to take the time to introduce the calculator methods of doing regression here.